Okay, I'm delighted to introduce myself.
No, please.
Oh, okay.
May I? I practiced.
I'm not sure.
So, welcome everyone to another exciting edition of the CCOM Seminar Series. And it's our honor today to have an esteemed guest who's traveled far through snow and storm and ice in particular. Dr. Larry Mayer, he's the Director of Center for Coastal and Ocean Mapping, the co-director of the NOAA UNH Joint Hydrographic Center, and the Dean of the still somewhat new UNH Marine School. He will be speaking today on his exploits and explorations in the Arctic, specifically a mapping expedition in 2015 in the Petermann Fjord. Is that correct?
Petermann.
Yes. Previously, Larry had earned his bachelor's from the University of Rhode Island in 1973 and his Ph.D. from Scripps in 1979. Very good. And I will
Great, thank you.
leave it to you.
What a nice introduction. Well, that's very nice. Okay, so this kind of came up at the last minute, and it really came up because Kelly gave a talk last week and just assumed that I had talked about the Petermann Glacier cruise, which I hadn't, so I felt bad about that. I also felt bad when I heard rumors coming from the student body that the director never gives a talk. I give talks all the time, just not here. But I do here too, but the students are only here a short time. So every few years I do give a talk. But also because it was just one of the most wonderful experiences I had in my life, and I thought it'd be nice to share that with you. And so some of it will just be a little travelogue, because this really was just an absolutely gorgeous place. There were a number of players that some of you know. Martin Jacobson was involved as kind of the Swedish co-chief scientist. Alan Mix from Oregon State University was involved. Myself, Kevin Jere here, claims he was on the cruise. I have found no evidence for that fact yet, and I'll demonstrate that clearly. And Kelly Hogan, who you met last week, we were kind of the main mapping and not geophysical, but the mapping type team. And there was a very, very international scientific party, 58 scientists, 6 countries. It was based on, it was really quite interesting, an NSF proposal that Alan Mix and I wrote with Ann Jennings from Instar. She's a paleontologist, looks at dead bugs and dates them, which is very important up here. You'll see why. And I'll explain why we went up there and what we were going to do. The idea was this cruise was going to take place on the Healy. Thank goodness it didn't. It never would have worked on the Healy, I guarantee, and you'll see why in a few minutes. And when we were on the Oden last year, it got funded, and NSF said the Healy wasn't available, and we suggested, what about the Oden, the Swedish icebreaker, which is a little different than the Healy. And they started to explore that possibility, and this is the first time that NSF actually paid for an operation like this on a foreign vessel, and there's now a formal MOU between Sweden and the U.S. for joint scheduling of both the Healy and the Oden. I'm hoping that will spread even further. So that worked out nicely, and that once you get involved with the Oden, you get involvement from the Swedish Polar Secretariat and all their wonderful logistical support crew, which really was quite spectacular. There was also, as you know, Kelly was from the British Antarctic Survey, so they were involved too, and I think I've covered everybody. Martin, University of Stockholm. As I said, it was really one of the most amazing places I've ever been to. And just to give you an idea, the air draft of the Oden is 50 meters. So you start counting up, and you see that's almost 1,000 meters high there. And that's just kind of every day, look out the window and see things like this. Really, really, really quite spectacular. Petermann Glacier is in the northern part of Greenland in the Narrow Strait, separating Canada, that's Ellesmere Island, who's our Canadian experts here, from the northern part of Greenland. The Greenland ice sheet, which Kelly talked a little about, but all of you should know, has a large amount of the world's fresh water in it. If the Greenland ice sheet melted, we'd have a global sea level rise of 7 meters. I knew there was a 7 in there somewhere. But this is, as you'll see, of great concern is the stability of the Greenland ice sheet. Jack spends a lot of time up and around in there.
Our special guest, Dr. Fonstock, worries about these things too. All the way from Alaska.
From Alaska, all the way over there. Well, welcome. Thank you. That's great. And this really is what has brought so much attention to this area, is the fact that the melting of the Greenland ice sheet has certainly accelerated quite a bit over the last few years. Here's a comparison of the number of melt days in 1979. 3 or fewer is the white, red is 12 or 75 or more, and you see 1979, very few 75 days or more of melting, while by 2007, that has tremendously increased, and I assume it's just increasing more and more. It's funny, I looked and I don't see many more recent, they all seem to stop about 2007 in terms of this. Is there some?
Oh, you should look, 2012 is a big event.
Yeah, I've seen individual things, but comparisons like this always seem to be kind of that time frame. 2002, most of them are showing. I don't know why. So maybe it's this world is slow to get the papers out.
No, they're all done in real time now.
Okay.
They don't get single graphs like that out.
Okay. Yeah. So it's a much more. Okay, and in terms of the loss of this ice, there's lots of thoughts about why. I'll give you a list in a few minutes of some of the reasons why there's this rapid acceleration and melting. But somehow this idea of ice shelves, floating ice that Kelly talked about last week, may play an important role. They may play a role in buttressing. It may play a role in terms of circulation underneath it. And so part of the idea is to try to understand what the role is. One of the places where a large portion of ice is coming out of Greenland, and again, I'll ask the experts to correct me, is in the area of Ilulissat, a place called Jakobshavn, where the glacier is coming down again into what was some time ago a very large ice shelf, and I think most of that ice shelf is now gone. If we look at the history in terms of the retreat of the ice shelf, we see there's been a phenomenal retreat of the ice shelf, and this is allowing almost direct input of the land-based icebergs coming from the land-based ice into the ocean, and it's a highway there. If you sit in Ilulissat, you can just watch these icebergs calving. You hear them, and they just come. And I forgot what I read what the percentage was of the Greenland ice sheet. That's it's 30% or so of the Greenland ice sheet.
These are the experts, Mark and Ryan.
Well, if it comes out of Jakobshavn?
Yeah.
It's about
10%, okay. And I think Petermann also has the potential in terms of the flow, although it's not producing icebergs like this now, and you'll see why. Because in Petermann, there still is a very large floating ice sheet. So in terms of the thoughts about why the melting is accelerating, there's the idea that higher meltwater production, again, climate-induced, enhanced basal water pressure, reduced friction, so it's a kind of a feedback mechanism. Here's the one that involves the ice shelves, in particular, sudden loss of buttressing as the ice tongues and the ice shelves break. They stop that buttressing. Responses to air and sea ice variability, and the inflow of warmer subsurface water, ocean water, towards the glacier grounding lines. And this has to do, this is very relevant to our world of bathymetry, because this requires some kind of passage of warmer waters into the fjords, and then allowing that warmer water to the glacier grounding line. And if you remember, I gave a talk a couple of years ago about a sailboat venture that Martin and I took, also in western Greenland. And what we were doing was actually mapping to see if there was indeed a deep passage that would allow warmer water into the fjord areas, and indeed there was in that case. If we look at Petermann, the Petermann ice shelf itself, it is a fairly substantial ice shelf. It's now about 70 kilometers back to the grounding line, but it has had some significant losses quite recently. In 2010, a very, very large piece of the ice shelf that's always described as 4 times the size of Manhattan. I used to live there, but I don't, it's 200 blocks this way, and 10 blocks that way. Broke off a very large piece in 2012. That was followed by a piece about a quarter of the size of that. But so in that time, it lost about 30–40% of its extent. So the 2010 ice shelf came out that far, retreated back. It of course moves forward again. Then 2012 retreated back again to the red line, and has been slowly moving forward again. So it's starting to undergo some very, very rapid degradation, and that's part of the uncertainty. What is causing that, and how does that degradation relate to what's happening to the ice sheet itself, to the glacier on Greenland, and how does that control it? So these are all part of the questions we tried to ask. Is the ice shelf response independent of or linked to the variations in the grounded Petermann Glacier? Is the glacier itself forcing it, or is it vice versa? Is it related to ocean thermal conditions, relative sea level? And in terms of relative sea level, as you'll see, and if you remember from Kelly's pictures, there's often a sill formed at the furthest seaward point of the glacier's extent. And so there's a marker, a paleo marker of where that extent was, and how does that sill depth control what's going on now. Interestingly enough, here's Petermann Glacier 2 now, looking at a bedrock elevation. This is done through gravity imagery, gravity modeling of the bedrock, and most intriguingly, there seems to be a very, very deep canyon that runs through a large part of the mainland of Greenland, leading right into Petermann Fjord. So clearly, for a long time, there's been a passage of both ice and perhaps meltwater in that direction. Okay, so this was a multi-component program. We went out there as mappers, but there were many, many other people involved trying to put together this very, very complex history of what went on. Of course, the mapping component we talked about, and this is some of the track line. Obviously, we had track lines in here too. You can see the coverage. There was basically very, very little bathymetry. There was a little bit of Amundsen bathymetry in there and a Healy line that came in a few years before, but we had very little pre-existing bathymetry. The mapping team, Martin, myself, Kelly you met, and Kevin, supposedly. But we also had Christian Strand, who's come here as a postdoc. He's back in Stockholm right now. So here, Kelly looking at the multi-beam data sets.
Maybe Kevin took the picture.
Christian Strand. Kevin didn't even have a camera. And so again, we're looking at Christian is processing of the multi-beam data, but here we see the water column mapping with the EK 60/80. I'll talk about that in a few minutes, and the SB120, the sub-bottom imagery there. But again, no evidence that Kevin was there at all. We had a major distraction in the cruise. It really was. Unlike their visit here, where the 60-minute team, a different 60 minutes team, was quite accommodating. These guys, I think, were anything but accommodating, quite demanding. You know, they were the big news media, and it really was disruptive for several days, and probably cost the Swedish government $500,000 easily in excess helicopter time and stuff like that. And if you saw, they did a very nice episode again, I think, in telling the story, but for all the time they filmed there, very little from the ship itself. We had also a program of seismic profiling run by a Danish group, the Danish Geologic Survey. The black lines here representing the seismic profiling, and that's to get not just the most recent history with the SB120, the sub-bottom profile from the multi-beam. We can see the most recent history, mostly the sediments, but to try to understand in a much longer time scale what the history of the region was, where there are much, much older events there. And so the seismic team used a relatively short 300-meter 48-channel streamer. It's very, very difficult to collect seismic data in ice conditions, as Dave Mosier knows. Where's Dave? Somewhere around here. And these guys are probably the best at it, except for the Canadians. But now I'm very mad at the Canadians right now. So, so you can see they're all the good ones are retired. You can see the streamer there, but these things are very, very vulnerable to the ice. Both the streamer and the air gun, which is this one 210 cubic inch GI gun, and they have special ways to tow it quite deep right behind the vessel, which isn't good for the vessel, actually. They've actually had some occasions where the constant shooting of the air gun ruptured a seal on the propeller shaft, and we're very, very concerned about that. And they're still very concerned about that. This is one of the very rare conditions where they're doing it in open water, but for the most part, they're doing it nice. And then, of course, we were amazed that it actually worked, but where was Kevin?
Is he still listening? Is he here?
Yeah, he's here now. Was he there?
He's been here the whole time.
Well, for all I know. This guy, I asked him. I said, we have thousands and thousands of pictures here from this cruise. I could not find one picture with Kevin. I went to Kevin. I said, Don't you have a picture with you in it from this cruise? No. So not just the geologic picture, there was also obviously an important question about the oceanography. A fellow named Andreas Munchau from University of Delaware was out there doing mostly CTD casts. You can see the CTD casts here in these little check marks. So there are about, I think, 47 of them. I'll talk about them in a little while. In terms of, you'll see some of the profiles from them in a few minutes. So again, trying to understand what the circulation patterns are, the water properties are in the region. So again, CTD and samplers, so rosettes for sampling. Marine mammal observations, this started as a requirement, but we actually had a marine mammal observer who was really quite a good scientist, and this actually probably is going to lead to the first paper from the cruise in terms of the distribution of marine mammals. You can see these little, all these little dots here, distribution of marine mammals, mostly seals, quite a few polar bears. The marine mammal observer, no Kevin. The Oden, if you remember the picture, has a very, very low fantail. It comes actually right down to the water line. And several times bears came literally right up to it, and several pictures of the bear putting its paw up on there. It could easily have climbed up, and fortunately didn't, because there were folks with guns standing there, because as cute as they look, they're not so friendly. Coring, this is probably the most important component with respect to the mapping, because as Kelly talked about, the record that we see of the history and direction of the glacier from the cores themselves, we now can put that into a time frame. So when did the glacier advance, when did the glacier retreat? And so there are again about 50 cores, the white dots all around. At each station there was typically a piston core, so a long core to try to get back as far back into time as we could. And then a multi-core, which is a core that samples just the surface material in multiple samples to try to really preserve the sediment water interface. And then a gravity core, which is kind of in between, a couple of meter long gravity core, because it's not so easy to core. And I didn't bother showing the picture, but oftentimes the core would come back with a cobble or a boulder or something, following it up, and the core pipe would bend over. You'll see why in a few minutes. That's a multi-core there. It looks beautiful, it is beautiful, but it's actually quite cold when you're doing this too. These guys are out there for many, many hours. And then finally, I think probably the first time in Greenland, at least, I think, where there was drilling on the ice shelf itself, below the ice shelf. The BASS team came out and set up camp. They actually moved out there for about 35 days. And supplied by the helicopters, and we would visit them every once in a while, but set up camp, 3 different camps, and set up stations where they would have a drill rig and both monitor the water column conditions in the hole they would drill, but then also take samples of the seabed below, up until the grounding line, which is back about here. I think about 70 kilometers from the ice front to the ground.
How thick was the ice they were on when they were at camp?
Yeah, so the ice at the shelf front edge, the ice was probably about 70 meters thick, and I think it got thicker and thicker as it went back until you reached the grounding line. There was also a series of beach surveys around all these areas, and the land team. The land team was a surprise. This was something the Swedish Polar Secretariat kind of put on, and this was a team of ecologists who were just out collecting bones and scat and trapping animals. And they were quite remarkable, because the boulder team, the beach survey teams, and I'll talk about the boulder team in a minute, these were people who were kind of transported by helicopter, spent a few days transported somewhere else. This Swedish land team, and here's where they were up here, and then they had a second deployment out here, they would just put out for 25, 30 days. And, you know, that was it. I think I assume they lived off the land. I don't know. They came back looking quite healthy, though, good smiles on their faces. And so for the beach teams, these were really interesting. You can see here a series of beach terraces, old stands of sea level, and the idea was to sample those and try to date those and try to understand at what time was sea level at what level. And then that helps understand also the rebound history, to put everything in a context of relative sea level. Getting there is not so easy. I said, Jack, I assume you guys do the same kind of way. There's an Air Force base in New York that specializes in C-130s or sometimes C-17s. You're lucky you get a C-17 with skis on them. And so they're the ones that kind of deliver people to Thule, Greenland. It's not that comfortable inside. It's noisy, it's cold, it's long. And on the C-130, particularly the C-17, which is a jet, is actually a little faster, a little less noisy, a little more roomy. But it gets you there. You land at Thule, which is an Air Force base at the top of U.S. Air Force Base, and they kind of quickly whisk you through. They don't quite like having visitors onto a boat, a transport boat, and onto the Oden waiting. And then we take off from Thule to make our way up through the Narrow Strait to Petermann Fjord. Initial problem right away, as soon as we got around the bend here, was, and it's really hard to tell in this thing, very, very heavy sea ice. This is this area over here. And you can see from the track that it was very, very heavy sea ice. We had scheduled, I think, 3-4 days for transit. It actually took about 6.
What month were you there?
We left on July 30th, so we didn't get up there till August 6th or so. And we were hoping to get up there a little sooner. And here's where I say it's different, I think, than the Healy. The Healy probably was a little more powerful icebreaker, but the Healy does not carry helicopters, has no mechanism for ice reconnaissance, and the only way we actually made it up there and actually made it into the fjord itself was through a tremendous amount of ice reconnaissance. They use the helicopters just like a taxi cab to just get up every few minutes if they have to and take a look where is there a clear path, and they'll guide the vessel from the helicopter, because we often had ice conditions like this. It's a very narrow strait. It's really, there's not much accommodation room for breaking ice, so it's kind of difficult. But again, they just fly around and they just start pointing spots, and you'll see in some of the tracks of the vessel, the vessel will just kind of move around. And it's not doing it blindly, it's doing it with that guidance, so it's very, very helpful. And so that is a way we picked our way through.
What kind of thicknesses could the ship go through?
Oden is probably okay for about 2 meters of ice, I would say.
Depends very much on how much tension is.
Right, it's not the ice, it's this issue called accommodation. You always need to have a place to push the ice, so it depends on what's.
Ooh, that's pushy buttons.
It was all ice. That was all ice. See how much I said? So that's really what, so you need, if there's a lot of compression coming from the wind, then even the Russian nuclear icebreakers are in trouble. On our way up, we passed this place. Anybody recognize that? If we had a Dane and a Canadian in the room, they'd all recognize it. Dave knows. That's Hans Island. That sits right over there, and it's directly on the border between Denmark and Canada, and both countries claim it. It's a huge border dispute that's led to a number of Canadian-Danish wars. It's true. It's true. So every year, the Canadian military comes to Hans Island, and they leave a case of Molson beer, and that's or Canadian Club, and that's followed by a series of Danish soldiers who come, who drink all that, and then leave a case of Carlsbad or Akavit or something like that. And this happens year to year, and this is the classic Canadian.
They leave Gamble dance.
Yeah, Gamble dance. Yeah, so we were gonna actually stop and put a Swedish flag on top, just to kind of create a little issue. Okay, so we
get Dan Oliver to leave a 6-pack of Budweiser there.
and then everyone would disown the place. So we finally did get up there. I said on the 6th of August, but what we found was that the entrance to the fjord was also very heavily blocked by ice. Inside the fjord, and we were getting wonderful support from the University of Minnesota in terms of satellite imagery. Inside the fjord was quite open, but it was very difficult to get there. And we were fortunate because actually this small piece of ice broke off, and it actually eventually plowed its way out, and we were able to follow its track back in. And again, through a combination of lots of satellite reconnaissance, you can see here, can anybody see the Oden in there? That's the fjord up here. That's the ice shelf, that's the Oden. That's that piece of ice shelf that broke off, and that carved a little path for us. And again, through that use of the helicopters for reconnaissance, we were able to make our way in. And once we got in, quite clear for a number of days, although it can change very quickly depending on the wind patterns. So that's the edge of the floating ice shelf. So that's probably about 10, 12 meters high, 10 meters high or so, and so you probably got 70, 80 meters of ice below that. They carry 2 helicopters on the Oden, using them, I said, all the time. Again, these are 700 meters, 1,000 meters high in terms of the cliffs of the fjord. This is not, there's a couple of these little riverlets, but there was actually quite amazing, a large river right in the middle of the ice shelf that came out, and the ice shelf teams, because they use hot water to do the drilling through the ice shelf, would set up camps next to the river. So because normally they would have to melt the ice and then heat it up. This way they can just use the river water and save some energy. But I think I have a flight just to show you how beautiful this river was here. And that runs again about the 70 kilometers to the grounding line area, to the glacier itself. And I guess somebody said, Jackie might know about it, or you guys, like a group from Greenpeace or something, kayak down it or something. I don't know.
No tubing?
No tubing, yeah. And so there's the Bass Ice Camp. Basically individual tents and their main tent and their drill rig and so on. So they set up 3 of these, and the helicopters would come after a week or two and move them to the next one. And so it was.
That's the same river?
That's the same river, yeah.
How deep is it?
It's not deep at all, and it varies. That was one of the really intriguing things. I was only there a couple of days, but you'd see a huge variation. Was that tidally forced? Was it?
Probably, yeah, maybe tidal.
Yeah. So we actually have, and they haven't been analyzed yet, but we have GPS stations there. So we're seeing, is it the ice shelf moving? Is it the water level moving?
Martin didn't put his little boat in there.
Martin didn't put his little boat.
It's not, is
I'm
it
surprised you didn't try to
What?
swim.
Is it navigable?
Well, so I said Greenpeace came down on a kayak. They did from the. That's all I heard. But it would freeze too. So I caught it at the time. In the course of the day, it would freeze up too sometimes. So you got to be quick on your kayak.
Couldn't send the Zodiac in.
Well, you could, and just have to bring it out. Okay, so let's start looking at some of the results. Again, the multi-beam, which is EM-122 1x1 system. I'm not going to show you any sub-bottom profiler records, but they have a very interesting system on the Oden. It's an 11-channel multi-beam sub-bottom system. Nobody quite really figured out what to do with the 11 channels, the 11 beams, I should say.
Yeah.
And the idea is that, in theory, you can see the 3D surface all at once, but it hasn't quite been figured out yet. So most everybody just looks at the center beam, but we might have people looking at that. We have that data available to look at. And those are a little wider, 3x3. And so if we look at some of the mapping results, and it really is quite spectacular. We have, here's the fjord here, the ice shelf on this end, and we have the Canadian side, the Greenland side. You see this remarkable change in the geology from, where's Wally? What do we have? These are old meta sediments here.
Greenland, yeah.
Yeah, clearly all jointed. You see you see a fault running through here, quite a change, and on the Greenland side, it's mostly limestones. And so you can just see that difference in there. Also something I only recently noticed is there's also a fault that runs right through here. And look at the next fjord that's offset itself right on the fault tree. It's really quite remarkable. So there's a really interesting story in there. That wasn't the story we were going out to look at, of course. We didn't really have a real geologist on board, tectonics type person.
What are the depths?
What are the depths? 1,000 meters in the fjord, and everything else is much shallower. And yeah, I don't have my machine. I was going to have the live scene in there, but yeah, about 1,000 meters is the deepest in the fjord. Just a little closer look at these amazing jointing patterns now looking into the fjord. But the real thing we were looking at was basically the history of the ice sheet itself. And you can see several indications. There's a sill, a grounding line here, a grounding line here. And there's some debate about whether this represents a third grounding line. I don't think so. We call it, this is much too much too sharp, I think. I think this is really a structural feature, but these two here are clearly grounding lines here. So at some point, the ice sheet came all the way out to here and all the way out to here. And that's a question that we're trying to answer with the cores.
Which two, Larry? I'm sorry.
That one here and this one here. We'll take another look here. Here you go. So here's the first one. So here's coming out, the ice stream flow coming this way. It stopped here, plows all that stuff up, forms that grounding line. It looks like there was yet another one out in here. And so the idea is with all the cores, with the 50 cores in this area, to try to date that.
Did the ice sheet widen as it went out from the enclosure, or?
Yeah, probably.
So it covered that whole?
Yeah, and I defer to my ice experts, but I think the evidence is that from what we see on the seafloor, that it did widen as it comes out. Comments, Jeff? Nope. Okay. So, and this is the kind of stuff Kelly talked about last week, all the evidence on the seafloor of the motion and the extent of the glacier. And again, with the cores, try to put that into a time frame and get the history of that. Relate that to the paleoclimate conditions, because the cores also have a record of climatic conditions, and relate it, at least in the modern time, to what the oceanographic conditions are now. So you have a kind of a modern snapshot, you have paleo snapshots of oceanographic conditions and the time frame. And so that's the whole idea. And it doesn't happen instantly, it's going to take some time. We only came back in late September, early October. And you can see just here clearly these streamlines here of how that seafloor has been modified by the glacier. Along with the seafloor mapping, Kevin and I really were out there to do some water column mapping too, and the idea was to do as we had done the year before in the Oden on the Siberian margin, so to see if we can use their fishery sonar, the EK60, which is a split beam echo sounder that allows you to get the position within, by comparing the phases of returns from targets in the water column through the different quadrants to get an accurate location of their position through something called split beam processing. Kevin's thesis is all about this. Tom does this in his sleep. The idea was to see if we can use that to look at seeps. And the seeps we were looking for there were potentially natural gas seeps or maybe even freshwater seeps. Fjords are sometimes known to have freshwater inputs into them. So that was the idea. There was an enhancement to the EK60, which is a topside enhancement that turns it into something called the EK80, which is a much broader band transducer. If we just look at this, I think there's a slide either from Tom or Kevin. I don't know whose slide. Raise your hand if it's your slide. Tom's slide. Where looking at the raw observations before the split beam processing of what a gas plume would look like, looking at what happens when you can use that split beam processing to really locate much more accurately the position of the bubbles themselves or a scattering from a group of bubbles, and then just a comparison of the two. And so you can really bring down the resolution of where that target is from. What the EK80 does, the enhancement, is try to let this system operate over as broad a band as possible, as wide a frequency range as possible. So if we look at the frequency range centered around 18 kilohertz for the bandwidth of the EK60, and we look at what we measured in the tank, the EK80 to respond at, we're looking at something at about 15, 16 kilohertz out, it depends where you take the usable cutoff, 20, 25, maybe 30 kilohertz in terms of a much broader band, a much wider frequency range. And the whole idea of this, and this is tied into, again, to a lot of the work that Tom is doing, and Liz, where's Liz? If you look at Liz's poster out there outside, she's been doing some of this kind of analysis on bubbles, seeps that we found off the Siberian margin last year, or 2 years ago. The idea is that there's a fairly well-established theory for how bubbles respond as a function of frequency, and there are known resonances. Resonai. These bubbles will resonate at particular frequencies depending on their size, and that theory is well established. So if we can make a measurement over a broad enough frequency range, we may be able to see some of those resonances and then see from that estimate the size of the bubbles. And if we can estimate the size of the bubbles, the understanding of how target strength responds to bubble size is well understood enough that it may be possible to actually get a flux measurement of gas. So that's the theory behind what Tom and Liz are working on. And I think if you look at Liz's poster, you'll see there's been some small success in that direction. And so we had that EK80 on the Oden again this year to give you an idea of what else the EK80 does. Increased bandwidth, of course, for all you junior acousticians. And bandwidth means resolution, of course. So the time resolution afforded by that increased bandwidth is much better than a narrowband system. So if we take a look at a series of targets, and these are fish, not gas bubbles, or scatters of biological scatters of some sort. They're actually given their little parabolic shape there. They're probably individual point scatters, so probably are fish. That's what they would look at in a narrowband mode with an EK60. These same targets with a broadband mode. So we're getting much better temporal resolution. And so a much more accurate description of what the targets might look like. So that was the idea as we were coming up. Supposedly Kevin was on board monitoring this thing all the time. Not a seep to be found. We finally found one clearly, well, I think well-defined seep. I still believe it's a seep. As we were coming up, and not another seep at all until we got to this area, and this only after we'd come out of all the work in the fjord. When we were working off here, there's a place called Joe Island here. Working along this edge here, here's the fjord in here, looking at all the CTD stations here, and actually a much closer look at some of the spectacular geology there. I also did want to point out something. This here. Remember Kelly was talking about these drainage channels around features? I'm starting to think that's exactly what we're seeing here, some kind of meltwater pattern around. This is such a strange channel here, and it doesn't look like the same structural control. So it looks like some flow that's being controlled by that, what we call the shark fin here, which originally they thought was a grounding line, but I don't think it is at all. So I think we are seeing some enhancement of the topography and flow. But down out here, outside of the fjord, we did see another clear seep-like structure. That was on the 17th of August. We came back about 10 days later when we were finally starting our way home, and we did not find anything. We went back to that same spot, did not find anything there, but just along strike, at the same depth, basically, we found another feature looking very similar. And while they were out there, Martin and I don't know who else was on the skin blotter. We were exploring, I'll show it a little later, another tiny little unexplored, never explored fjord over here called Bessel Fjord. So the Oden was waiting and they were looking at this. And then a few hours later in that same area, this one at exactly the same depth again, all at about 350 meters or so. And then a further upslope, a huge something. And so I started to think this doesn't look like gas at all, but maybe fresh water. I mean, we might be seeing fresh water, and we now have some geochemical evidence. It just came out. Actually, I just got in New Orleans last week that the pore water chemistry from the cores is showing that there are fluxes of fresh water. There are many aquifers along you'll see if you look along the side of the fjord, there are waterfalls coming out from the middle of the fjord. It's not just melt from the top. And so there are layers, there are porous layers that actually can feed fresh water. So we're thinking it might be related to that. No idea. This is all brand new. Okay. The other interesting thing we started to notice as we were surveying in the fjord with the water column data is that there was a very strong, in this case at about 90 meters or so, a very strong midwater layer. We first noticed it typically at the mouth of one of these tidewater glaciers, these glaciers that are coming on the side. You see there's several of them, one here, several of them up here. And when we'd see this huge midwater scattering layer. And we thought at first we were actually seeing a plume, again, of fresh water or sediment coming off the glacier, but as we started to trace it around, it was just too ubiquitous. And I don't believe it's that. I think it's biology, like a scattering layer should be. But what's so intriguing is the behavior of these scattering layers. It's very, very consistent and very spatially coherent. And what we see, and you'll have to take my word, because we've looked only at the at these layers at each one of the CTD stations. So you're seeing the salinity, temperature, and density record at the CTD station. Is that anywhere in the fjord, in the deep fjord, every one of those stations there has a scattering layer that looks just like this, which is basically very shallow and basically tied to the base of the halocline, so the salt layer. So right at the bottom of the rapid increase in salinity is the top of this layer. And so there's that kind of thing. We see it also, this is on the EK80, I should point that out. We also see it on the EM122, the multibeam sees it too, it's that strong, that scattering layer. Here it is again, the same one, that's another spot here. But again, always at about that same depth at the base of the halocline. And if you come back to the office, we can look, but every one of them in the fjord is like that. If we move outside of the fjord, in this area here, totally different. We're now down at about, what is that? 300 meters. And way, way below, obviously, the halocline. Nothing in the CTD and the oceanographic structure there, but every one of the ones in that area had that characteristic.
No oxygen in the CTE yet?
No values yet. Yeah, don't ask. And then if we move to the Canadian side, and the small area over here, which really had me confused at first, and I think I have an explanation now, all the ones on the Canadian side had absolutely no scattering layer. And so the first question I asked, and I don't know the answer yet, but I think at least everything I've seen so far, these are all, I'm just plotting them spatially. Let me go through the spatial plot, and you'll see what that looks like. And here's just a place. The only other place it was not existent was over here. And that's the transition, just to show that it's something real. We're just steaming along, and it just stops as we're moving out into here. And if we look at the distribution now of the depth of that scattering layer, these are all the shallow ones, the deep ones, and non-existent and non-existent. So they kind of group like that, and then like that. And this is the one that really bothered me until we just, again, in New Orleans last week, I got the first results from the physical oceanographers. And what they're seeing is that the inflow into the fjord is coming along just like this. And so we may be, this is the water coming into the fjord. That's all I know right now about it. So there's something, I think something truly, truly intriguing there. Here we're just, what was the question? Who asked the question? Oxygen, there was some of the question that I was going to come back to.
Dissolved oxygen.
Yeah, no, there was something else that I was going to come back to about here, and I said, we'll see it when we see the distribution, but it doesn't matter. Okay.
Did you
so
measure turbidity in that?
they had no turbidity measuring capability. I was so frustrated that I would go to the water bottles, and as they were siphoning off the water, I was taking coffee filters. Seriously, just to see if there was anything in there. I could not believe it, that they had no capability on the CTD. And Christian, who comes from that organization, which is actually the University of Göteborg that provided, he said they have them, they just didn't think to bring them. And so it's really, this is the thing that kills you. You should, that's why you should always have everything you possibly can have with you. I mean, seriously, no, you never know. What?
Twice, in case one breaks.
Twice, in case one, yes, yeah, exactly. We tried little GoPro cams we put down there, and we'd see, you'd see there are white dots, but yeah, but you're right. I mean, it would have been fantastic to have turbidity. Okay, so all I've done is analyze this at the 40 or so CTD stations, but the beauty of this is that we continuously, that EK80 is on all the time. So we have a continuous trace through the whole, everywhere of the distribution of that layer. We just have to analyze it, Aaron. Hopefully, our thesis. And Kevin has already done some, he wrote a MATLAB script. I started to analyze it looking basically at the basically geotagging the imagery so we can see its distribution. Kevin was actually extracting some of the targets, and there's some thresholding issues there. But we have this really phenomenal data set to hopefully look at whatever the distribution of this is continuously through the whole area. But we have to understand what it is, and we don't right now. I don't feel bad now, but if I come back next year at this time and still say we don't understand it, then I'll feel a little worse. So the final thing I want to touch on is what Kelly touched on, Martin's little toy, his ski bladder, his little launch with an EM2040 on board. And so this was really just fun. I mean, he was going to do this no matter what, no matter what the captain said. But unfortunately, he gets along well with the captain. I think you saw this picture. So it's Kelly, Martin, and myself off for a little trip. That had to set up its own kinematic stations. And so these are the helicopter pilots who just at a moment's notice, oh, you need that? Oh, yeah, just, yeah, we'll put it up there. They just loved going out doing anything for any reason. It was really a very, very different attitude about use of the helicopters, which was critical. And so we wanted to get in front of some of these. The Oden itself wouldn't get too close to the tidewater glaciers or any glacial front. It's dangerous. And so we wanted to see if we can get map a little closer to the shore. The captain, of course, said not too close to the captain's job, but of course, Oden went away, so we got pretty close. And you'll see in a minute. It was so this some caves in them and things like that. And so here is now approaching. This is the 2040. Approaching. This is our closest approach, and then turning back away as we came towards the Tidewater Glacier. And what I want to zoom in on is not the seafloor. I'll show you the seafloor in a minute. But what I was most intrigued with was the water column. Just spectacular in the 2040, the resolution in the water column. This is a stop for a CTD station, the CTD going down, the CTD coming up. Anybody have any idea what that is? That's a seal that was sitting up there. We saw it, took a dive, tacked the CTD, knocked air bubbles off it. I mean, it's really quite remarkable. I think Martin actually has a picture of the seal itself. What about this one? Anybody know? Loch Ness Monster, yeah, obviously. That is the Loch Ness Monster. No, I have no idea what that is, but it's
the Loch Petermann Monster.
The Petermann Monster. But what I now want to show you is some water column imagery coming into that Tidewater Glacier. Again, you should now be able to orient yourself. Remember the old grounding line. You see that, the second grounding line. Maybe that's more convincing, Andy, from that perspective. So the grounding line and the grounding line. Certainly, you can see what's going on there. And I've got the whole scene. But I don't think we're going to take time to fly around that. But now we're just going to look at the water column there. And so we're zooming in a little more, and we see this spectacular target in the water column there as we get closer and closer to the glacier itself. And here's it now in a cross section coming in. I used to have units on there, but we're now probably just about 70 meters of water here or so. And now I'm going to zoom in. And what we're seeing, I think, is this is the freshwater sediment-laden plume coming out from the Tidewater Glacier. And now that's just zooming in right in. And I think we're actually seeing sediment that drops out. It gets thinner and thinner, and we can actually start. And so I want to kind of hook up with some models. Lots of people love to model this stuff because we actually can see some of the dynamics of what's going on here.
So is that right at the surface of the water?
That's right. That's the surface. Yeah.
You should at least mention the sub-bottom floor.
That's not sub-bottom. That's just a that's a 2040. So it's not sub-bottom, but and we didn't have a sub-bottom, unfortunately. But it would have been spectacular because this is one of the things I'm wondering. I really have to think about that. Is this a very, very low density sediment plume sitting near the bottom? What am I seeing here? This looks like the real bottom, but there's something here too.
Yeah.
So it might be just.
Did you stack the fan? It's probably just your.
It could be. Yeah. That's exactly right. So it could be an artifact of the processing that the outer beam is seeing something slightly offset. Yeah, that could be. So we have to be careful about that. Yeah. And then finally, the skid surveying right at the base, and we were literally. I mean, we could throw stones at the glacier. Fortunately, the captain wasn't around. And looking at the interaction of the glacier on the seafloor itself, it's now retreated slightly, but it's interacted with the seafloor. And this is again all this stuff that Kelly was talking about, all these spectacular, these kind of chatter marks as the glacier is moving in and out. So here we're at 50 meters or so, 53 meters out there, a little shallow. This is going up to a few meters. And finally, I said this unexplored. This is just something Martin had to do. I mean, we had to go into Bessel Fjord. And if you read the history of this Bessel was a doctor who killed somebody else there was an expedition that the group got into a battle. One group killed somebody in another group, and then they split up, and they were actually on 2 different ice islands, and were both rescued. It was really quite interesting. But we don't think anybody's ever actually been in there. And so he kept wanting the Oden to go in there, and the captain just said, no. And so finally, we said, well, let us explore it with the skid bladder, which we did. And good thing. And it was actually very, very tricky, because there were lots and lots of icebergs that we had to skittle around. But the bottom line is that the Oden could never have gotten in.
Still across the front.
Yeah, across, yeah, up 7 meters. Yeah, and the Oden's draft is 11. So captains are right usually. That's the other lesson. And
By definition.
So we didn't even go beyond that. So actually, even a little skid bladder, because we didn't know about the title. What the title? We thought we were very embarrassing to have to call the captain to come rescue us, and actually the radios weren't working too well. So we found a beautiful large grounded iceberg out there that we went around and surveyed, and again with the captain out looking. I just wanted to show you this picture. You talk about dirty icebergs and things like that, and you wonder why you try to take a piston core, and you can't, because of all these things that carry and stuff like that, and that all gets trapped out on the bottom. Can you imagine trying to core that? And that's why the cores are having problems all the time. But we really did get, as I said, quite close to it, and we got a wonderful, nice survey of that grounded iceberg, and you can see the plow mark that the iceberg made as it grounded. It's really quite cool. Okay, so let me just end by saying this is one of the most wonderful experiences of my life, just in beauty and scientific interest. It is, I think, a phenomenally complex but exciting data set that's just really untapped at this point, and I think it'll be harvested for years, and we're writing proposals already to go back to the next fjord up to really try to capture an entire system. Now we have a much better idea of what to look for. We think we know how to do it a little better, but I think it will keep us busy for some time, and hopefully some students too. And finally, I did solve one mystery though. Finally found the picture of where's Kevin. Unlike the Healy, the Oden has 2 or 3 saunas. It has 2 saunas. It has a beautiful lounge. That's only half of it. That's the bar. And so I think that's where Kevin was. Okay, thank you. And I'm happy to answer any questions.
Any problems when you were surveying that freshwater near the surface in terms of effects on the bathymetry, like Jones Sea and Victoria?
No. Yeah, it's really interesting. We were dipping quite a bit, so I think we had the structure. And I think the difference is that what John sees in Victoria is a much more dynamic surface, and probably the contrast is probably even greater than we're seeing. But he has a tremendously dynamic sediment plume laden surface, and this was very gentle. You saw how calm it was out there. When it was thin, we were below the layer. The layer itself's not that thick, and we only got into it thick, just right at the base of the glacier itself. And I don't think, well, you saw the bathymetry. The bathymetry still managed to hang in there. And we'd stop and take a dip. You know, it was so simple. He's got a beautiful little, on the skid bladder, it's a little fisherman's winch. And it's just an electronic winch. And with a sound speed probe on it. And we just zoop, dip it down, dip it back. We can do it every 10 minutes without a problem. And I think we just probably had enough capture of the differences, and it wasn't, as John's saying, this really roiling dynamic surface that it probably just didn't have as much of an impact. I think a lot of it also has to do with whether you're disturbing the surface or not from the vessel. I mean, we saw that on a much larger scale on the Healy when we were sitting off the North Slope. When we were sitting again in a kind of freshwater layer, everything was fine. When we did the dip, the minute the vessel started going, everything went to hell because we were disturbing the freshwater layer, and then it was giving all kinds of structure that we couldn't compensate for. But in this case, we didn't seem to have a huge problem.
So the water column image showed quite deep
return, but how much of that is the freshwater, do you think, based on your CTD that you were doing?
We didn't have a CTD on the skid bladder, and we only had a sound velocity probe.
So can you infer it from that, though?
Yeah, and
Do you have a sound speed profile that shows?
Yeah, we
Just
do,
wondering how-
we,
what the relative.
right, and I don't know the answer. I mean, I'd have to look. Yeah,
So
it's a
expect
good
all that
question.
water to be relatively fresh.
Fresher.
At that time of year, the Arctic is hemorrhaging fresh water down in areas into your gyre.
Larry?
In the one of the last photographs you showed of the glacier front, and it was covered with the sediment, not on the surface, but down the,
Side?
is that sediment cascading down, or there?
Yeah, no, it's not, it's stuck.
It's
kinda stuck.
The face of it?
Some of it's
How-
buried
how
in
did
the
you
ice.
get-
What?
Trying to get a sense of how much sediment it went back into the glacier.
I don't know.
Obviously, it's not a wedge that.
I don't know. I mean, I think it depends on where it came from. This may have come from scraping along something, and then it went deep in. In other cases, this was a stream, an old stream bed that was carried along, and so that, if that got buried later, that would go way back deep in it. So I think there are all different mechanisms for creating it, so it depends on the mechanism. We saw, when we got it to Petermann Fjord, it was very, very interesting, because we clearly saw the trim line of an old glacier. That was really spectacular. I mean, you can just see how there was a level of the glacier that just really scraped along the sides, and then you'd see the moraines that followed along outside of that. So it's kind of the classic glacial process is really in action. Tom?
You mentioned the circulation briefly. What were the flow rates typically?
I don't know. I mean, I ran into Andreas.
Measured on the pump vessel?
No.
You had the shipboard ADCP or something?
No, there was no ADCP on the vessel. That's another problem. And all we have is, Andreas has just started to analyze those 40-something CTDs, and has put together that,
I was inferring the circulation from the CTD.
Yeah.
No actual.
Right.
So there wasn't much wind there. It looked like, I didn't see a lot of.
not in the days we took the pictures.
So is there much wind or? Wind?
Yeah, I'm sure there is sometimes, and we had some, were you there?
Yeah.
We had some very windy days, and what would be remarkable is, I could go on for hours with stories in terms of I always call it the Canadian defense system. The ice would be clear right up to the boundary between Canada and Denmark in the Narrow Strait, and it was impenetrable. And then sometimes a few hours later, it would move across the other side. So we always had to be quite flexible in terms of how we surveyed, and that's what the beauty of using the helicopters. You can see where things were, and we'd always kind of be able to pick a place where we could work.
I forgot what your tidal elevations were, or range?
I think the tidal range was probably on the order of 1 meter to 2 total, because it's significant.
Potentially some significant
Yeah.
tidal drive in some
Yeah.
places.
There is tide gauge data there, there's persistent glider presence in the areas, and there have been bottom-mounted ADCPs there in previous years.
And a lot of that, Andreas was.
Well, Andreas knows about some of it.
Did the sub-bottom data just show a really highly reflective surface like that would show?
We didn't have sub-bottom data on the skid bladder.
No, but say out in the main part of, or did you have thin transparent sediment?
We had some thin transparent sediment and some places where there was a hard bottom, and nobody's really looked at the sub-bottom data in enough detail to really make sense of it yet.
How many cores did you collect?
About 50
So
cores.
you were getting some penetration.
Some cores penetrated, some cores, yeah, I think the longest core was probably about 8 meters maybe. And
8 meters?
8 meters, yeah. And most of them probably were on the 5 to 6 meter, and many of them were 0. Yep.
So from the CTDs or from your water column imagery, is there evidence for a lot of fresh water coming in under the glacier?
Okay, so this is the.
I mean, you showed the rivers on the top, the
This is the
meltwater.
million-dollar question. And that's what we first thought we were seeing, was that. And so this, again, the visit to New Orleans, and Alan Mix was there too, and he's now seeing evidence for fresh water coming in certain places, and he thinks it's bedrock controlled again from the bottom. And so my job now is to go back he's given me those locations. He's given me the end members of where there's unequivocally freshwater, where there is no freshwater. And I'm going to take a look at the water column imagery. We don't have CTD stations there, but I'm going to look at the imagery and basically see if we see something different. And I don't know, but that's a great question. Glenn?
Were you able to see those seeps in the 122, not just the K60?
Yes. Yeah. The seeps were, yeah, we're seeing them in
Where
122.
they were in the summer.
Yeah. Yeah.
I was just gonna comment on your comment about helicopters. The Oden doesn't have a helicopter. They're contracted, same with Seawood. And the SPRS has a very different view of when it's cost effective to pay for helicopters compared to NSF.
But I'll tell you, once they get on board, they don't seem to, I mean,
Yeah.
never once did he say, oh, this is gonna cost us too much to do.
Because Sven thinks it's a lot more fun flying on the Oden than
Yep.
it is herding caribou
Sure.
in Lapland.
But, I mean, but they got to the point, and it wasn't, and I know they did go over their helicopter budget because it's CDS. But still, despite that, towards the end of the cruise, Ulf, the project manager, was basically saying, who hasn't taken a ride in a helicopter?
Was he stop with you?
Yeah.
He didn't sail very much.
No, he doesn't, no, but this
For
was-
this expedition.
This
he'd go-
was,
go see, yeah.
even the Swedes who do this all the time, this was a highlight.
Some of your seeps look odd,
Yeah.
which I think you recognize.
Yep.
And they were higher target strengths up near the surface, and their morphology
Okay.
looked weird near the surface. And I'm wondering what you think is happening.
Okay, so one or two things. One is if they are freshwater, they're coming up, even those seeps that look like gas seeps, maybe freshwater, and then the freshwater is spreading, it's a jet coming up. But I don't think that's what's happening.
It would make it weaker acoustically up near the surface, would it not? Maybe?
Maybe, I don't know. But what I really think is happening, and I think Kevin will comment on this, is that the vessel tended to maneuver when it was around those targets. And what we found is anytime the vessel was maneuvered, you get this, it's actually a vessel, it's a function of the vessel, bubbles, the vessel is generating in its maneuver.
Oh, can you go back to one of those seat pictures?
Kevin, do you want to comment on that?
Is he there?
Where's the lounge? Is he in the lounge?
Hey, Tom, are you talking about the?
Well, it's they spread out on top.
I'm not sure. I think we have a couple examples where the ship was not maneuvering immediately after. And,
That one.
Like that.
Yeah, like that one. Like these
Yeah.
are continuing.
Like
straight
like
off
this.
the,
That's down
And you
over
see that-
100 meters though, that it's spreading out.
Yeah, you see this, oh, but we did see, we saw the influence of the ship maneuvering
Oh, definitely. Yeah.
to 100 meters without question. We would see that just, with no seeps or anything. If we would just sit there and be maneuvering at a coring station, you'd watch those bubbles and they'd go down 100 meters.
Okay.
Yeah.
So even you think the freshwater seeps have a lot of bubbles? That's the target? The acoustic
No, I think one possibility is we're seeing something come up and spread on the surface, but the other possibility is as we were hanging out, because these were kind of hanging out, as the ship is maneuvering, that you're seeing two different things. You're seeing, this is not something coming down, I don't think. This is something coming up, but this is the vessel maneuvering above. That's
So there's been published papers with diving birds actually.
diving birds. No, I know, you told me about this, yeah.
I didn't believe it, but
Yeah.
it looks just like that actually.
Yeah, well,
And it could explain some of the surface activity.
could be. It could
Do you
be.
have an idea how to, seems like a difficult one to sort out. Do you have
Well,
an
except
idea?
our marine mammal observe birds too, so we would know if there was a bird there.
Yeah, we not to totally discount it. I don't think we saw too many birds actually.
Yeah, yeah.
Yeah, a lot
No
of
big
gulls.
herds of puffins or?
No, there were virtually no birds, and never a narwhal. And that's the whole reason she came out there, because this is a place where lots of narwhal have been found, and there was nary a narwhal. But it was a sure way to get her to come running to the bridge, is to start claiming there was a narwhal. Yeah, so if we go back to that first one, see, this first one doesn't have that. Whoop. Oh, a bird. Okay?
Well,
Thank you.